one final example of undetermined coefficients here. If we start working at this, it looks simple, but there's a twist waiting for us. So let's try solving this. The right-hand side is just e to the 3t. F of t is just e to the 3t. So our particular solution, we'll just let be a e to the 3t. So far, so good. We can find y prime would be 3a e to the 3t, and y double prime would be 9a e to the 3t. And then substituting in, we get y double prime, that's 9a e to the 3t, minus 6 times y prime, plus 9 times y. All that equals e to the 3t. So again, just sort of aligning coefficients, since e to the 3t appears in everything, all we're looking for is the coefficients on the left side, which are 9a minus 18a plus 9a, and that all has to equal 1. Now what happens here? If we try solving this, something interesting occurs. This left-hand side just collapses down, and we get, well, 0 equals 1. And that seems like a big problem, right? So that can't be true. So somewhere, something happened. Something went wrong. So the question is, what happened? And it turns out that this, at first, seems like something we wouldn't have expected, or there's no way to know that this would have happened. But I mentioned this earlier, that there's a certain case where our particular solution happens to align with part of our homogeneous solution. So just to note, we didn't do this with this example, but it turns out that the homogeneous solution is c1 e to the 3t plus c2 t e to the 3t. So if you solve that homogeneous case, you would get r equals 3, or negative 3. Sorry, r equals 3. So there's only one possibility, r equals 3, and so you have these two independent solutions that form the homogeneous one. And so since it was given to us, since it turned out that the f of t is similar to one of the pieces in our homogeneous solution, there's no way that our particular solution can be a e to the 3t, because we already have something like that in the homogeneous solution. And again, the whole point of superposition relies on the assumption that they're linearly independent. So we need to have an independent solution from the homogeneous one. So just to note here, yp has to be independent, linearly independent, of course we mean here, from the homogeneous solution. So it's got to be independent. So that breaks down. So what do we do? The solution to this is very similar to what we did earlier. Back when we were talking about the homogeneous case, we looked at examples like this, where we get a single value for r, like 3 in this case, and we said, okay, we have one solution that just uses that value of r. To get a second linearly independent solution, we introduce this t into the problem. So what we would do here, our first recourse, would be to just make yp be a t e to the 3t, right? As soon as we notice that it contains part of the homogeneous, we would bump it up to t e to the 3t. Now what's the problem with that? The problem with that is that this still fits the other part of the homogeneous solution. So say, for instance, yh were c1 e to the 3t plus c2 e to the 5t, and we ended up in this situation, then this solution would work. We could pick a t to the 3t. But since in this example that also shows up in the homogeneous solution, we need to go one step further. So basically we just add t's, or multiply by t, until we are not matching anything in the homogeneous solution. So this one again doesn't work, but let's pick t squared e to the 3t. And it turns out this works, and it seems kind of hacky, but remember that all we're looking for is a particular solution. Any particular solution will work. As long as we find one of them, the full solution will be the sum of the homogeneous and particular ones. So we pick this, and we can find a value of a that will make that work. So from then on, the problem looks just like we've done before, and I'll go through and finish it just to show you. But before I do, how will you recognize that this happens? There's a couple ways to recognize. One, if you end up in a situation like this, where this is an impossible situation to solve because all of these collapse down. If that happens, that tells you immediately that this is a homogeneous solution. And you can think about why that's true. Basically, if these things all combine down to be 0, it makes sense that it's a solution to the homogeneous case where it equals 0. So that's the idea there. So if you notice that happening, you recognize that you need to do this adjustment. The other way to notice this is simply to do the homogeneous part as the first step in your problem. If you get in the habit of always doing that, then if this situation arises, you'll recognize that you'll need to do this, and you'll actually recognize it before you start doing the problem and kind of waste your energy getting to this step. So if you do the homogeneous solution first, you can save yourself a little bit of effort by recognizing this is going to happen. So a couple ways you can notice, but again, it's kind of a fail-safe. If you start working on it and you get to a step like this, that should kind of be a clear sign that you need to stop and try something else. And that's what's going on in this example. So just to quickly sort of round out the example, y prime using the product rule for the derivative would be 2at plus 3at squared times e to the 3t. And I won't bother going through that. You can pause the video and check that for yourself. But that's what you get when you use the product rule. And then the second derivative, if you do this product rule again, you should get 2a plus 12at plus 9at squared e to the 3t. And then substituting everything in. So again, the original question was y double prime minus 6y prime plus 9y. So y double prime minus 6y prime plus 9y equals e to the 3t. Now it looks like a lot here, but if you notice, there's really only one coefficient over here, one undetermined coefficient a. So it's not as bad as it looks. If we multiply all of this out, all of these t e to the 3t and t squared e to the 3t, the t e to the 3t, t cubed e to the 3t, all of those should equal 0, right? Because there's no t squared e to the 3t, no t cubed e to the 3t, no t e to the 3t. All of those have to be 0. So we could multiply this whole thing out and recognize that, but just notice that all of those have to go to 0. So for instance, we have 12a t e to the 3t, and here a minus 12a t e to the 3t. So 12a minus 12a has to equal 0. Now this actually doesn't tell us anything, right? So it's kind of superfluous. Tells us nothing, because you just get 0 equals 0, which is trivially true. Then if you do the same thing here with t squared e to the 3t, we have, sorry, there's a mistake here. This should be back here. This should be t squared, not t cubed. T squared. So we've got 9at squared 9at squared, and then this one as well. So 9a minus 18a plus 9a all of that again has to equal 0 because there's no t squared e to the 3t on the right hand side. However, again, that doesn't really tell us anything because again, you just get 0 equals 0. So when you start doing this, the reason there's sort of these equations that don't give us any information is because we are only looking for one coefficient. And so we have ultimately 3 equations to find one unknown. So 2 of the equations are extra. They don't really do anything for us. So all that's left then is the 2a e to the 3t, and that has to equal e to the 3t on this right hand side. So pretty easily you can tell that a has to be 1/2. So we have 2a equals 1, so a equals 1/2. So the final solution is yp equals 1/2 t squared e to the 3t. And we know what the homogeneous solution is from back here, so the full solution would be this plus this. But we're focusing on the particular solution, so I'll focus on that there. So this one looks complicated. There's a lot of details on the algebra here, but again, the key of this example was just showing what happens if your particular solution form happens to match one of the pieces from your homogeneous one. So whether you recognize that by finding the homogeneous one first and comparing, or whether you find it by making this guess and then along the way running into this situation where you get 0 equals 1. However you notice it, the way to fix it ultimately is to step up to either a form like this by adding on or rather multiplying by a t, and then if you have to go one step further, you can as well. So that's the key to this example.